Hey guys, here's the booklet on inverse relations. I'm going to be doing one graph and one algebraic example. So here's example 1A in your booklet. Obviously, I've drawn it on the whiteboard here so you guys will have a little bit of a better copy. So when we have the inverse of a relation, the easiest thing to know about inverses is whatever the original xy points are, it's the exact same mapping notation every single time. It's going to change from xy to yx. So every point that you have is going to flip from x to y and y to x. So I have the old points written out here that you guys can see on the graph. And now what we're going to do is we're just going to rewrite them, flipped around, might get off the screen a little bit. Hopefully it doesn't. We got 1, -2, 2, -1, 2, 1, and 0, 2. Okay, so hopefully you guys can see those points right. So now we got those 4 points we're going to put on the graph. So we got 1, -2, 2, -1, 2, 1, and 0, 2. Now, labeling these from A, B, C, and D would be a good idea. If you don't, just make sure that you connect the dots in this exact order that we got the points from left to right in this one here. So I have to connect them in that order this way. Okay, we got a little bit of overlap, but there is the inverse graph. One of the important things about inverse graphs that we need to understand is that there is a reflection happening, but the reflection is a little bit different than what we're used to. The reflection that we have in these questions are over the y equals x line. So I want you guys to draw in a y equals x line, maybe a little more straight than mine is there. Okay, if we remember, y equals x is just the basic straight line that goes through the center of our graph. And there's a note in your booklet on the actual notes online that talks about inverses are always the reflection over y equals x. Sometimes these questions get asked that way. Instead of saying draw the inverse, they might say draw the graph that reflects over y equals x. And that's a fancy way of just saying draw the inverse. So if you can kind of tip your head a little bit and kind of notice what happens this way, you'll notice that we have a reflection on this direction and that direction. They're exactly the same graph as we go through. Okay, domain and range is the last thing on this graph. So if we do the original domain and range, domain is -2 to 2, and range is 0 to 2. Now, when we have this domain and range, the note on the front of the booklet, if you started there, it says domain and range always flips itself, just like x and y always flips itself, but let's look at it visually. Okay, domain in the new one goes from 0 up to 2, and if you notice, 0 to 2 is the exact same as the range of the old one, and then the range is -2 to 2, which is the exact same domain as the old one. Okay, and that always happens. They always flip with each other. All right, and then on the next page, I'm just skipping over example 2, but use example 3 as a reference point. I just find example 3 a little bit trickier, so I thought I should show you guys that one. Okay, so example 3, as with every other algebraic question, whenever you're asked for the inverse of an algebra equation, you are going to flip. Instead of going y is equal to 3 over x minus 5, we are going to change that to x is equal to 3 over y minus 5. And now once we have that, we want to solve for y. Okay, we want to solve for y now at this point. So whenever you have a fraction like this, let's actually just rewrite it out here below so we have a little more room. You don't have to if you have some room on your page, but I'm going to multiply both sides by y minus 5. Okay, that's going to allow me to cancel that out. On the right side, I have 3, and then on the left side, I have x times y minus 5. Now what I'm going to do is instead of multiplying through doesn't really end up getting y by itself. It really just gives me more of an issue with x. So I'm actually going to divide both sides by x immediately. Okay, so again, I'm not going to multiply through. You can if you want to, but then you got to move 5x over. You got to divide by x again. So instead, don't multiply through yet. Just divide this out, and now you have y minus 5 equals 3 over x. And now you can just add 5 on to both ends. K to the -1 of x, that was our original variable, so we have to use k, is equal to 3 over x plus